Ladies and gentlemen, welcome to section 11.1, inverse variation, part 2. Please remember, inverse variation, you have y equals k over x, or xy equals k. We're going to be using this a little bit today, xy equals k. So what are we going to be asked to do? We're going to be asked to solve, and then we're going to say that y varies inversely with x. This is always true right now. Y varies inversely with x for these next 4 problems. So here we go. First problem asked, if y equals 5 when x is 12, find x when y equals 15. First part here though is we have to find k for this right here. How do we find k? We are going to use this. We have xy equals k. So let's go ahead and find k. X is 12, y is 5, and so that equals k. So k now equals 60. So that's the first part of it. K equals 60. Now for the next part. The next part goes, we have to write our equation. So y equals k over x, and k is 60. So it's going to be 60 over x. Now I'm going to find x when y is 15. X when y is 15. So what is y? Y is 15. That's going to equal 60 over x. Now how do I solve for x? Well, what's this look like? What if I put a 1 right there? Now what does it look like? Now we just cross multiply. 15 times x is 15x. 1 times 60, that equals 60. How do we solve for x? We just divide by 15. So x equals 4 for our answer. We need this x equals 4. So again, with 2, if y equals 4 when x equals 8, this is going to be the first part of your problem. Then we're asked to find y whenever. But this is our first part of our problem right now. So again, we take x times y, that's going to equal k. Well, now y is 4 this time, x is a negative 8, that's going to be k. So k now equals a negative 32. Now with this 32, we're going to plug it in for our y equals k over x. Now we have y equals, what is our k? It's a negative 32. That's going to go over x. So here's my equation. So my y is, I don't know what my y is because my x is negative 4. So it's negative 32 over a negative 4. Now, this looks bad, but we have our numbers on the both sides, so we can go negative 32 divided by negative 4, which gives us 8. So y equals 8 for our answer. Let's try a couple more like this. Again, we're going to be given x and y. We can just plug them into x times y equals k. So y is 4, x is a negative 8. That's going to equal k. K is now negative 32. Once we find that, now we move on to our equation. We move on to the second part where we write our equation. Y equals, our k is negative 32, and that's going to go over x. Here we are given y equals 2. Y equals 2 will go in for our y, so 2 goes in for a y. So it's going to be 2 equals a negative 32 over x. What do we have to do here? We have to put the 2 over 1 and cross multiply. 1 times there, which is negative 32, and that's going to equal 2 times x, which is 2x. How do we get the 2 away from the x? We divide, so x equals a negative 1/6 for our final answer. X equals negative 16. One more. Last one we do here, if y equals 2 and x equals 5, first part, we take care of business. X times y, that's going to equal k. What is our x? Our x is negative 5. So it's negative 5. What is our y? Is negative 2. We multiply that together to find our k. Our k is 10. 10 equals k. So that's the first part of it. Now you have to find the second part of it. We're asked to find y. Well, first we write our equation. Y equals, what's our k? Is 10 over x. Well, now we're given x. We're asked to find y. So y equals 10 over a negative 2. And so y equals negative 5. You like those problems, y equals negative 5. Two more examples here. We're still going to assume that y varies inversely as x, and now we're going to write an inverse variation equation that relates x and y, and then we're going to graph that equation. Well, first things first, let's write that equation. What do we have to do with these two numbers? We first have to find k. So we have x times y equals k. It's going to be 4 times 2, and that's going to be k. 8 equals k. So now for our equation, it's going to be y equals, and then just what we were doing before, 8 over that x. Your k goes over x, so here is our inverse variation equation. And now we're going to graph this. When we graph this, ladies and gentlemen, when we graph our x value, I want your x values to start with whatever you multiply to that number. So if it's 8, your x value is going to be 8. And our y coordinate then is going to be whatever you have to take times that 8 to get your k. So since my k was 8 here, my x is 8, my y is going to be 1, because 8 times 1 is 8. So now how do I get this 4? What do I have to multiply the 4 by to get 8? What do I have to multiply the 2 by to get 8? What do I have to multiply the 1 by to get 8? Well, 4 times 2 is 8. 2 times 4 is 8, because 8 is my k. 1 times 8 is my k. Here we have no solution for my x, because if I plugged in 0, right, and my y, 8 divided by 0, is no solution. And then how about negative 1 times a negative 8 is 8. Negative 2 times negative 4. Negative 4 times negative 2. Negative 8 times negative 1. Let's go ahead and graph these. Be very careful though with 8, 1, because we have to go over 8 and then up 1, which is right about here. Over 4, up 2. Over 2, up 4. Over 1, up 8. So let's connect these dots right away. Here we have a curved line. Make sure this is curved, and it will never go below your x value here, or your x-axis, and it will never go past your y at 0 or your x at 0. Now let's try the bottom ones. Negative 1, here it's negative 1, down all the way to 8. Then it's negative 2, negative 4. Now it's negative 4, down 2, and then negative 8, down 1. Again, we connect those dots. Notice what our inverse variation equations look like. Look at the graphs. You will have 2 lines and 2 curved lines, because you can never touch these lines that we'll find out later will be asymptotes. This is an asymptote of the graph that I will put in green right here, and right here is another asymptote of the graph. Let's try one more. Here, first thing we have to do when graphing is to find our k. How do we find our k? We just go x times y equals k. So we have a negative 4 times a 3. That's going to give us negative 12. Now, since we have our negative 12, let's write our equation. Y equals, k goes on top, negative 12 over x. So there is my equation. Then we're going to be asked to graph this. We have to get our numbers to be whatever we multiplied them to be. We have to get our numbers to negative 12. So I'm going to start with positive 12 and work all the way to negative 12. What do I take times 12 to get a negative 12? Well, that's going to be negative 1. What do I take times, I'm going to say negative 12. What do I take times 6 to be negative 12? What do I take times 4 to be negative 12? What do I take times 2 to be negative 12? Negative 12, ladies and gentlemen, is coming from our k right here. So 6 times negative 2 is negative 12. 4 times negative 3 is negative 12. 6 times negative, or 2 times negative 6 is negative 12. Here we have 0. 0 will give us no solution. Negative 2 times a, now positive 6 will give us negative 12. Negative 4 times a, positive 3. Negative 6 times a, positive 2. And negative 12 times a, positive 1. Go ahead and graph this. We are going to go by 2's on our graph. So this is going to be 2, 4, 6, 8, 10, and 12. Ladies and gentlemen, you could go by 1's, but you would need a bigger graph. So since I don't have a big enough graph, I am just going to go by 2's. It's not a big deal. It won't be exactly correct, but no graph is exactly correct unless you're using graphing calculator. So let's go ahead and try this. We have 12, negative 1. So we go over 12, down 1, down, 1 right there on the graph. Then we go over 6, down 2. We go over 4, down 3. We go over 2, down 6 right there. And then we go ahead and connect those dots. Remember, it's a curved line. Notice what's happening here. Since k was a negative 12, now our graph is going to be on different sides. Instead of here and here, it's going to be here, and guess where else? Over here. We have negative 2, then we go up 6. We go negative 4, up 3. Negative 6, up 2. Negative 12, up 1. Again, we connect the dots to the best of your ability. It's going to be a curved line, ladies and gentlemen, and a smooth curved line, so please make it a smooth curved line. Again, our graph will not pass here and not pass here for right now. And that does it for section 11.1, Inverse Variations, Part 2. Good day.